we're asked to write out all the functions f that map the set with elements 1 and 2 to the set with elements a, b, and c in two-line notation, where the set with elements 1 and 2 is the domain, and the set with elements a, b, and c is the codomain. Because each of the two inputs have 3 possible outputs, or because the first input has 3 possible outputs, and the second input has 3 possible outputs, and 3 times 3 is equal to 9, there are 9 possible functions. Let's go ahead and write these functions out in two-line notation. Let's label the functions f sub 1 through f sub 9. Remember, in two-line notation, we have the inputs in the first row and the outputs in the second row. For each function, the inputs are 1 and 2, which go in the first row of each matrix for the function in two-line notation. And that's where we're going to determine the possible outputs. For function 1, let's let both outputs be a, meaning 1 maps to a and 2 maps to a. For the second function, let's let both outputs be b, meaning 1 maps to b and 2 maps to b. For the third function, let's let both outputs be c, 1 maps to c and 2 maps to c. And now let's use the outputs of a and b for the next function. Let's let 1 map to a and 2 map to b. And now let's let 1 map to b and 2 map to a. And now let's use the outputs of a and c. Let's let 1 map to a and 2 map to c, and then 1 map to c and 2 map to a. And then we're left with using the 2 elements of b and c for the outputs. Let's let 1 map to b and 2 map to c, and then 1 map to c and 2 map to b. Now we have all 9 possible functions. So number 1, how many functions are there? Well, we can see there are 9. Number 2, how many are injective? A function is injective, or one-to-one, if every element of the codomain is an image of at most one element from the domain. Or we can say injective functions do not have repeated elements from the codomain in the range, but may have missing elements. Well, functions f sub 1 through f sub 3 do have repeated elements from the codomain in the range, and therefore these 3 functions are not injective. Or more formally, these 3 functions are not injective because every element of the codomain is not an image of at most one element from the domain. However, the remaining functions, meaning f sub 4 through f sub 9, are all injective because none of the elements from the codomain are repeated as elements in the actual outputs or the range. And therefore we have 6 injective functions. Next, how many are surjective? A function is surjective or onto if every element of the codomain is the image of at least one element from the domain. Or we can say surjective functions do not miss elements from the codomain in the range, but may have repeated elements. Well, all 9 functions do have missing elements from the codomain in the range, and that's because there are more elements in the codomain than there are elements in the domain, and therefore none of these functions are surjective. So number 3 is 0. Number 4, how many are neither injective nor surjective? Well, if there are 9 total functions, 6 of which are injective, 0 of which are surjective, then 3 of them are going to be neither injective nor surjective. And those 3 are functions f sub 1 through f sub 3. They're not injective because injective functions do not have repeated elements from the codomain in the range, which we do have. And they're also not surjective because surjective functions do not miss elements from the codomain in the range, and functions f sub 1 through f sub 3 are missing elements from the codomain in the range. And as we said earlier, actually all of the functions are missing elements from the codomain in the range, and therefore none of them are surjective. But again, functions f sub 1 through f sub 3 are neither injective nor surjective. And then number 5, how many are bijective? Bijective functions are both surjective and injective, which we have none of. We also say a function is bijective if every element in the codomain is the image of exactly one element from the domain, which we can see is not possible. I hope you found this helpful.